let's look at another example where we're being asked to find circumcenter. Find the circumcenter of a triangle, JSO, with the vertices J80, S06, and point O, which is at the origin. I'm going to go ahead and graph that. We have a triangle. J is at 80. That's 1 point on my triangle. S is 06. 06. That's S. And the other point is O, which is at the origin. Now we have triangle JOS. Now we need to find where the circumcenter is. Recall that if we can construct perpendicular bisectors of the three sides of a triangle, where they meet is called the circumcenter. Well, let's look at this. Since I have a horizontal side of my triangle, which is on the x-axis, notice it's how many units? It's 8 units. Can I construct a perpendicular bisector? Yes, I can. The midpoint is right here, which is at 4, and any vertical line is perpendicular to the x-axis. So I know one of my perpendicular bisectors. I'm going to go ahead and sketch that. And the equation of this line is x equals 4. That's one perpendicular bisector. Any vertical line is perpendicular to the x-axis. It forms a right angle. So here's one. What about this one? My y-axis. This segment SO, which is the side of the triangle, can I construct a perpendicular bisector here? Yes, I can. Since the measure of this side is 6, the midpoint would be right here at 0,3. That's the midpoint. And a perpendicular bisector would be a horizontal line parallel to the x-axis. Okay. Any horizontal line is perpendicular to the y-axis. The equation of this line is y equals 3. Notice I have a perpendicular bisector here. I have one here. For this line, perpendicular bisector. For this line, where do they meet? Well, if I have two of them, I know that third one's going to meet. What is this point called? Well, the coordinates of this point is 4, 3. And recall that a circumcenter is where at least 2 or 3 perpendicular bisectors of the sides of a triangle meet. Where they meet, that's called a circumcenter. And it does look like this point is equidistant from the 3 vertices.